Welcome back. Today we're going to be talking about graphing proportional rate relationships. This is day number 2. Our content objective is students will be able to graph proportional relationships. Language objective is students will be able to read unit rate answers from a graph. And why am I learning this? Well, it's important for many real-life example problems such as finding the cost per lunch. So let's just quickly go over some background knowledge. Remember that a proportional relationship will always have an equation in the form of y equals kx. For number 1, it says find the appropriate equation for the graph. So the very first thing I want to do is look at the line of the graph, and I'm going to look for nice ordered pairs. So this one would be the first ordered pair that I'd see. I see it goes through the origin, so I would use 0, 0. Now the next nice ordered pair, some of you may say, hey, this one looks pretty good, but here I'm going to say between 0 and 1, this would be a half, so I would be a half, 3. Now I could definitely use that one, but I have other options. So instead of doing a half, 3, I might do an ordered pair such as 1, 6. Now you might be asking, why did I go ahead and skip the half, 3? Because for me, I would prefer to work with whole numbers. Now, is it wrong to use this ordered pair as well? Absolutely not. But if I had a choice between fractions and whole numbers, for the most part, I will always choose whole numbers. So same thing here. This one's technically 1.5, 9. I can definitely use that. However, I think this might be a better choice, which would be 2, 12. And then the last one I see, again, I could use this one, which would be 2.5, 15, but I think this one would be easier, 3, 18. So remember, when you're looking for the constant of proportionality, and I am going to need that in order to figure out the equation for my graph, I am going to do two things. I'm going to show you both ways. Number 1 would be to check the ratios. Let me actually work that out for you so you can see. So the ratio is always going to be set up as y over x. Now I'm not going to really use 0, 0 because that's not very helpful for me. So I'm going to go straight to 6 over 1, which is 6. I could have done 12 over 2, which again is 6. Or I could have done 18 over 3, which is also 6. So by using the ratios, I would be able to say that the constant of proportionality is 6. Okay? And it shows here, you can think of it as a constant multiplier. When I multiply all of them by 6, it actually gives me the output. So now that I know the constant of proportionality is 6, I can go ahead and plug it into the form y equals kx. I'm able to use this because I see that my graph is linear and I see it goes through the origin. So I know for sure it's going to be in the form y equals kx. So here, what is k? According to the ratios that I've checked, k is 6. So I'm going to replace this k with a 6, so my equation is y equals 6x. So all I did was replace k with the value of 6. So is there another way to find the constant of proportionality? Absolutely. Okay. Another way to find the constant of proportionality is to look on the graph for 1, k. So here it means that in 1 hour, how many pumpkins were carved? Well, we can see in 1 hour, 6 of them were carved. So we could have also saw that as a way to find k. Or could you also have looked at the table? Absolutely. It tells you right here, 6 pumpkins are carved in 1 hour. So there are various ways. Now, some ways would be better than others for certain scenarios. For example, it's not always given in a table, and you might not always clearly see what it is on a graph. So the ratio would always be your safest bet. But looking at a graph and looking at a table allows me to quickly figure out what the constant of proportionality. So it's a good idea to learn all 3 methods: checking the ratio, looking for the ordered pair in a table for 1, k. So in this case, when x equals 1, or simply looking at a graph for the ordered pair 1, k. So what's the unit rate? Well, we know the constant of proportionality is 6. Now it's just a matter of, okay, 6 what? Well, we like to do it as y over x. So I'm going to say 6 pumpkins per hour. So that's what I would write. Okay, so now let's go ahead and move on to number 2. It says, find the appropriate equation for the graph. So again, I'm going to want to look for some ordered pairs. So 0, 0 is a good ordered pair. However, keep in mind that this is not always the most helpful ordered pair, but it is an ordered pair that I can clearly see. Another one might be this point here, which is 3, 200. And I see another nice ordered pair here, which is 6, 400. Now I notice that's all I have, so I can't go more than that. So from there, I'm going to go ahead and check my ratios. So I check ratios as y over x. So I'm going to go ahead and say, I'm not going to use 0, 0. It's not helpful. So I'm going to do 200 over 3. I can't reduce that, so I would just go ahead and leave it as that. Now, let me just go ahead and check the 400 over 6. And guess what? This can be reduced by 2, and you would find that if you did, you would still end up with 200 over 3. So does it really matter which ordered pairs you pick to find the ratio? No. If it's linear and it goes to the origin, no matter what order pairs you pick, you should still end up with the same value for the constant of proportionality. So in this case, the constant of proportionality is 200 over 3. And it might be a good idea on a quiz or test for you to actually check to see if it works. Does 0 times 200 over 3 equal 0? Yes. Does 3 times 200 over 3 equal 200? Yes. The 3's cross cancel, leaving you with 200. Does 6 times 200 over 3 equal 400? Yes, you could cross cancel, leaving you with a 2. 2 times 200 is 400. So now that I know the constant of proportionality, I'm going to go ahead and put in the form y equals kx. Why am I able to do this? Again, because my graph is linear, it goes through the origin, so I know for a fact it's going to follow the form y equals kx. So the only thing we need to replace is k. What is k? K is 200 over 3, so my equation is y equals 200 over 3x. Now, are there other ways to find the constant of proportionality? Absolutely. Remember, the other way would be to look at your graph for 1, k. But like I said earlier, sometimes it's not going to be the best method. So here, I see 1 is here, but I can't identify this point exactly. I know it's a little bit over 50, but I can't give you a definitive answer. So that's when this method might not be the most helpful. Now, you can also look in your table. However, in your table, there isn't an ordered pair where x is 1, so that wouldn't be helpful. So what's your fall to method? It's going to be to check your ratios. Now, if it's provided in a table or if you can clearly see it on a graph, definitely use that to your advantage because it's a quick, easy way to figure it out. But keep in mind, it's not always going to be as clear like it is in this example and this example here. However, because we know the constant of proportionality is 200 over 3, I know this ordered pair is 1, 200 over 3. But again, I only know this to be true because I already know the constant of proportionality. It would be difficult for me to look at this graph and then come up with this conclusion. Okay, so what is the unit rate? Well, we know the constant of proportionality is 200 over 3. So now it's just a matter of figuring out what the units are. So what are the units here? I would just say 200 over 3, y per x. Why? Because they didn't give us any values, they didn't give us any units for y, and they didn't give us any units for x, so we just say y per x. Okay, so now that we've practiced some, I'd like you to go ahead and pause the video and try number 3 by yourself. Okay, so let's see how well we did. So first, we're going to find some nice ordered pairs. So let's try 0, 0, 2, 8 tenths, 4, 1.6, and 6, 2.4. Now, one thing I want to talk about real quick is, were these the only pairs you could have possibly chosen? The answer is no. You could have chosen, you had more options. You could have done 10, 4, which I personally like because they're both whole numbers. And you could have gone on and on and on, okay? And to be completely honest, do you need to have all of these ordered pairs to figure out the constant of proportionality? No, you only really need one. Keeping in mind that you're not going to want to use 0, 0, because that doesn't give you much information. But just to show you and to practice, we are using a few order pairs to really make sure that we have the correct constant proportionality. So you would go ahead and check y over x, so 8/10 over 2, 1.6 over 4, 2.4 over 6. Now, what does that reduce to? Well, let's see. So typically, first of all, I want to just give a disclaimer. We typically will write things as fractions because fractions allow us to be exact. However, in this case, I do want to write it as a decimal. Now, why would I want to? Because we're talking about money. We're talking about cost per minute. So it would be strange for me to express the value as a fraction. So I'm going to go ahead and divide this out. I'm going to use these two sets of numbers because they're the smallest numbers here. So let's go ahead and do that. We're going to do 8/10 divided by, let me go back real quick, by a 2. So bring that decimal up. So 2 goes into 8 4 times. Since we're talking about money, I'm going to put an extra 0 and say, okay, it's 40 cents. So here, I'm just going to say that the constant of proportionality is 0.4. So my equation would then be y equals 4/10 x. And here again, this is a great thing to check on a quiz or a test to kind of really ensure that the numbers make sense. Because sometimes we do make mistakes with some of our values here and we don't check it and then we end up getting the wrong answer. So now that we have the constant of proportionality, let's just discuss what we would know. On our graph, we would know that this 1 comma k would be 1 comma 4/10, right? So what is the unit rate? The unit rate is 0.4. I know that, but what are the actual units? Well, it's going to be dollars per minute. So since it's money, I would add an additional 0, so it would be 40 cents per minute. Okay, so last but not least, once again, why don't you pause the video and try this one by yourself. Number 4, find the appropriate equation for the graph. So first things first, let's find some order pairs. 0, 0 is a good one. 1, 8, 2, 16, 3, 24. So here what I want to do is first check my ratio so I can figure out what the constant of proportionality is. We always set it up as y over x, so we're going to exclude 0, 0 because that doesn't really help. We would check the ratio of 8 over 1, 16 over 2, 24 over 3, and you're going to find no matter no matter which values you choose, you're going to end up with a constant of proportionality of 8. Now before I finish and claim that it's my constant of proportionality, let me just check my table to see if it really is that constant multiplier. If I multiply 0 times 8, does it equal 0? Yes. 1 times 8 is 8. Yes. 2 times 8 is 16. Yes. 3 times 8 is 24. Yes. So I know for a fact that it is my constant of proportionality. So it's going to follow the form y equals kx. Why do I know it follows that? Because we do see a graph that's linear and it goes through the origin. So we're just going to replace k with our 8. So our equation is y equals 8x. So now that I have that, let's talk about what we should expect to see in a graph. Here, this was nice because it is clear that it is 1, 8. So if we wanted to, could we have looked at the table? Could we have looked at the graph and be able to come up with that constant of proportionality? Absolutely. But not only that, we also were able to see it in our table here. 1 for x, and then we saw the value of y was 8. So this is an indication of what the constant of proportionality is. Now keep in mind, it's not always going to be in our table or in our graph. It's not going to be as clear for certain cases. But in this case, it was. So would it be a good thing for you to know? Absolutely. Keep that in mind. So here I would know that it's 1, k. So what's my unit rate? I know my constant of proportionality is 8, but what are the units? Well, I'm going to go back to the units for y and x. Well, the units for y was dollars, and the unit for x was sale. So I'm going to say it was $8 per sale. Well, guess what? That actually concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye!